Welcome to Physics with Harry Potter. In today's lesson, we have Harry Potter here traveling on his broomstick across a Quidditch field that is 120 meters long. There is a wind traveling westward at 1.5 meters per second. That's going against him. And he wants to go northward. So we want to find the direction he needs to travel in order to counteract the westward wind and travel north, straight. So if we draw a vector here, we can see that he needs to travel at some angle theta in order to travel straight north. And in order to find this angle theta, we know that in the problem it says Harry Potter is traveling 3.0 meters per second maximum along some direction in order to counteract the west wind, which will be denoted by this vector here. And the reason he travels this way is because if we draw the vectors head to tail, we see that these two cancel out to give a northward direction. So we want to use cosine because cosine is adjacent over hypotenuse, which in this case will give us our adjacent 1.5 meters per second over our hypotenuse 3.0 meters per second. Now in order to find the angle theta, we need to do the inverse cosine of 1.5 over 3, which is 1/2. And we know that inverse cosine of 1/2, we plug it into our calculator, look on a unit circle, is going to give us an angle of 60 degrees. And this angle is going to be 60 degrees north of east. So he needs to travel at an angle 60 degrees north of east in order to counteract this west wind and travel straight north. So next, we need to find out how long does it take Harry to fly across the Quidditch field and score the snitch. In order to do this, we want to use our Pythagorean theorem. So we know that Pythagorean theorem is a squared plus b squared equals c squared. And right now, we don't know our a squared. That's x over here, the measurement of the north in meters per second. So we're going to leave that a. But we do know b, 1.5 meters per second, and this is going to be squared. And then we know c, 3.0 meters per second, also squared. So now we do some algebra. Move this over to this side to get a by itself. We get 9 minus 2.25, and that gives us 6.75. We want to take the square root of 6.75 to find a, and that gives us roughly 2.6 meters per second north, which is right here. So we're not done yet. We have the velocity at which he's traveling north, and we have the total distance he needs to travel. So rearranging the equation for speed, we get time equals distance over speed. And in this case, we know our total distance is going to be 120 meters over our total speed that he's traveling north across the field, which is 2.6 meters per second squared, meters per second. We cancel out the meters. Our seconds is going to go to the numerator. Now we just need to divide 120 by 2.6, which gives us about 46.25 seconds it takes him to fly across the field. Thank you very much.